There are trends of physical properties across the periodic table that we can use to predict relative properties. All of the trends across the periodic table form a diagonal from the lower left to the upper right of the periodic table. Some of them are highest in the upper right and some of them are highest in the lower left. Atomic radius is maximum in the lower left. As we go down the periodic table, we add electron shells. Each electron shell is larger than the one before it, so the atomic radius increases as we go down. As we go across a period from left to right, we're adding electrons to that one shell, but the shell is actually getting smaller in size. That's because as we go from left to right, we're also adding protons to the nucleus. So we're increasing the electrostatic attraction between the nucleus and the shell, so the shell gets closer to the nucleus, so the radius shrinks as it goes from left to right across the period. Of course, we know that upper right of the periodic table is nonmetals, lower left of the periodic table is metals. So metallic character, the ability to conduct electricity and similar properties, is the highest in the lower left of the periodic table. Ionization energy, that's the energy required to remove an electron from a gas phase atom to produce the gas phase ion. This is an endothermic process. We know that metals ionize easily, so metals have a low ionization energy. The nonmetals do not like to ionize to form the cations, so they have the high ionization energy. And this high ionization energy is highest with helium. For electron affinity, this is the opposite process of adding an electron to an atom, a gas phase atom, to form the anion. For the anion to be stable, it has to release energy. That's the electron affinity, the energy that is released when an electron is added to a gas phase ion. And of course, we know that nonmetals like to form negative ions. The nonmetals release the most energy, so they have the highest electron affinity, except this stops with fluorine and does not continue on to helium. Helium does not like to ionize. Fluorine is the most likely to form a negative ion. We also have electronegativity. This is when we share electrons between two atoms. That sharing is not always equal. It's an unequal sharing at times. And electronegativity is a measure of how unequal that would be. With the higher the electronegativity, the more that atom is holding on to electrons, the greater the share the electrons that atom gets. And of course, we know that nonmetals like to get electrons, so nonmetals have the highest electronegativity, and this again ends with fluorine, which forms those covalent bonds, and does not continue on to helium, which does not form covalent bonds. So to be able to use this trend to predict relative properties, we'll use electronegativity as the example. If we compare calcium and barium, well, electronegativity is highest in the upper right of the periodic table. Upper right. So use those two terms. So calcium is above barium, so calcium will have a greater electronegativity. If we compare calcium and iron, again, electronegativity is maximum in the upper right, so iron is right of calcium, so it will have a higher electronegativity. If you compare iron and nitrogen, nitrogen is toward the upper right from iron, so it will have the higher electronegativity. If you compare iron and silver, well, silver is toward the right, but it's below. So this is not in the direction of the trend. The trend is lower left to upper right. Well, iron and silver are on a upper left, lower right, the opposite trend. So this one we cannot predict. We would have to look that one up. But for a lot of elements, we can just use this trend here to do a quick prediction of of the relative strengths of these properties of the elements.